Hello. Thank you for choosing to attend my session. I'm going to start with a little story. So about 10 years ago, my grandmother was living in independent living and she had a fall in the middle of the night and no one got to her until 6, 7, 8 hours afterwards. She broke her shoulder and was never the same again. So she had a button on a wall to ask for help, but obviously if you've fallen, you can't press the button and ask for help. So that's part of the inspiration for my startup, which I'm going to talk about today. So we're going to talk about the problem we're solving, which I've sort of given you an overview of that already. We're going to go through requirements, persona gathering of who cares about this sort of product. We're going to talk about minimum viable products and minimum lovable products. Are they the same thing? Well, let's find out. Enriching events. It's all about data, it's all about events. You need to know where these events come from and which systems they've passed through. Data partitioning, we'll cover a bit of real-time escalation and some key takeaways. So the typical aged care room is basically has some tech, but it's pretty antiquated. So you've got pressure floor mats for identifying when people are walking in certain areas of the room or falling out of bed. You've got bed alarms. If someone sits up in bed or falls out of bed, you need someone there pretty quickly to look after them. And there's infrared switches as well, so they can be put on doors to know if someone's gone into a bathroom or whatever. The problem with all this tech is that it's old and it's, it can break down, and these are very expensive things to put into an aged care facility. So how can tech help? So I've drawn a diagram of an aged care room. They're all the same, like similar layout. So you've got a bed and you've got a bathroom. Most falls happen at night, and it's the highest rate of injuries for elderly people over 60. So the tech that we're going to put in is a millimetre wave radar device. It looks like a little smoke alarm. It goes in the roof and it emits a radar and it bounces off bodies, objects in the room. And so it can identify the XY coordinates of where that person is and how many people, and the Z coordinates, so centre of mass, so you know if they're up or you know if they've fallen. So there's machine learning on board which can send an event to know whether someone has actually fallen and you can get help. So understanding your persona, you have two personas in an aged care facility. You've got the facility manager who cares about reporting, prioritisation of care at the right place at the right time. They also need to record falls for compliance purposes in most countries. A nurse needs to understand when someone has fallen and when they need help. And again, prioritisation of care. So both requirements, the aged care facility manager, most of those needs can be done by a batch. All the other ones need to be near real time, because as soon as someone falls, someone needs help, you need to get to them. The current tech doesn't allow for that, but this does. So IoT Core is a key piece of this infrastructure. So the device talks to IoT Core to send events. So what is IoT Core? It's basically an MQTTS, MQTT WebSocket compliant endpoint managed. You don't have to worry about managing your own MQTT endpoint. It provides all that for you. An IoT device publishes an event to this endpoint. There's rules that you can configure on how to deal with events as they come in, and then you have actions which gives you ways to process these events. So an event payload looks like that without the bullet points. Bit of a technical error there. You have a device ID, you have a location in the room. So I said XY coordinates and Z, that's them in relation to the device. You get a event name, what was the event, the time it happened, and the type of event. So a minimum viable product is when you spend the minimum amount of time coding something So I used a Grafana dashboard. So I needed to get on board with a vendor who provides this device to make sure I could be a partner. To do that, I need to show I understand their products and I can query the data. So this Grafana dashboard is literally just wired up to Athena and CloudWatch at the back end. CloudWatch for obviously the little graphs there, and there's some reporting from Athena. Very easy to wire up Grafana to AWS services, and it's a very easy way to show a dashboard. I also did a little demo video. My son features in that and falls. Well, he will fall. There we go. He gets up out of bed and he falls, and then there's an alert that comes through to say. So all of that was done via Grafana dashboard and a Lambda function at the back end. So I like architecture diagrams. So this is the original architecture diagram of what I built. So you can see that there's the customer device talks to IoT endpoint, and it goes through a transform Lambda function to send an alert. So that was the alert. There's also CloudWatch logs. They're also going to CloudWatch logs as a JSON payload. And something not as well known, you can have CloudWatch log metrics based on these logs, which don't cost very much, and have your own custom metric filters. Very useful. So that way I can get those graphs of people being in bed, custom things, people in the room, out of the room. And there's a persisting the event, obviously, for querying from Athena. That goes via Firehose to S3. And then, obviously, the Grafana dashboard is consuming all these things. There's a little database to say who should get alerts, and that's basically my MVP. So an MVP allowed us to understand the data, be able to query it intelligently, even. Answering business questions. So, I can show it to customers and go, what sorts of things do you want to see? So it helps that dialogue discussion with potential customers. Not so good. In this case, the data is only set up for a single tenant. I can't scale this. I can't scale Grafana dashboards. So I need to solve those problems. So one of those problems was adding tenant context to that payload. Because that device doesn't understand the concept of tenants, it understands itself, a device, but I need to put it somewhere. So I had to grab a Lambda function to enrich that payload, so that data goes in, it gets enriched on a Lambda function, and I'll show you an example of the enrichment at the end, in the next slide. We have, then that republishes to a different MQTT topic path, which has the tenants at the beginning of that path. So I can easily query, I can see all the events coming through for the right tenant. And then a rule can grab that, and I've got a separate Firehose for each tenant, keeping all tenants' data separate. And then I've got an SNS as part of that to be able to do real-time processing for those events that I care about. So this is an example of querying the event stream when it comes in. Topic 4 in this case is basically you count from the slashes. So before the slash is 1, the first plus is the tenant ID, devices is number 3, and then after the devices is device ID, so that's topic 4, so that gets put in as a device ID in my payload, and then you can see I've got a Firehose delivery stream there for topic 2, which is the tenant ID, so I've got one Firehose for every tenant, keeping the data separate. So an example of an enriched event, you can add a meta key or something, and you can add that as the data goes through your pipeline. So it gives a time, where it got enriched, some trace IDs, etc. So when you're partitioning this data in S3, there's 2 ways to do that. There's the Hive style where you label the partition, so year equals 2025. That's the traditional way of partitioning. It's the standard way. In our case, there's also non-Hive, so where you're doing partition projection. Examples of that is CloudTrail, ALB logs. A lot of AWS services use that second method. So basically the difference between the two, if you're doing Hive style, you have to manually add that partition. When you go into a new day, new month, you need to fix that, make sure it's scanning that new partition. In partition protection, you can actually configure Athena what your partitions are, whether they're dates or whatever, and it can work out. You don't have to scan it, you don't have to add partitions, it's all added for you. So the second method is the best way to do it at scale, so I don't have to worry about missing partitions and missing data. So you configure that. Firehose can do dynamic partitions. So I just pull the year, month, day and device ID out of my payload. So any JSON payload that goes through Firehose, you can pull out that information and use that as part of your partitioning. So that's what I've done there. So I tell it, this is the path where I want to store my data. After doing that, I need to be able to, and that's what it maps to in my case. So you've got all the presence alerts for someone walking around. You've got a date, I've got a device, and then I've got data. So I can query by device, by date very easily. And then to be able to query that non-Hive partition format, you just put a configuration into Athena in the create table, and you tell it what the format of the partition is, its days, valid dates, all that sort of thing, and then it knows the rest. You don't have to do any more configuration. So the final part of the solution is falls escalation. That's a key point because you need to be able to escalate to different levels of people to make sure that someone gets to the person who's fallen. So the falls alert will go to a SNS event topic, and you can actually have a queue that listens to a particular filter policy. So in this case, my payload type is a fall. I only care about fall alerts to go to my queue. So my SNS topic will go to a queue. It goes to Lambda function, and then it goes to a DynamoDB table. And then I have a listener on the DynamoDB table, which is an event bridge pipe. So one of the good uses of pipes is that you used to have to use Lambda functions for this. In this case, you can configure the pipe to listen to the stream. You can do some enrichment. I'm not doing any enrichment in this case, but I'm kicking off a step function flow. So it's a good way to wire these things up. And then the step functions flow looks like this for the escalation. So about 6 months ago, AWS updated step functions console to provide a way seeing the data, seeing your different steps of your step function flow, and that's a nice sort of visual way of seeing my path. So the data goes through the first level, there's a delay, and then it'll go to the second level, and then there's a delay, and it'll go to the third level. If someone acknowledges that alert, the step functions will finish. It checks to see if someone's acknowledged it first. So I originally was a Grafana dashboard. The last few months I've been building out the website, and this is the settings screen, which basically shows the front-end user interface for the escalation flow. There's reporting via an activity timeline, so you can see if someone's in bed, in a chair, you can get lots of dates and times of people moving around. This is very useful data, especially in an aged care facility, to understand patterns of movement in a room, and also potentially to, if someone's doing something abnormally, you can actually send an alert to someone to see if they should be checked. And then there's a dashboard as well. So the key takeaways when you're doing a product, I call that a minimum lovable product. So minimum viable product is your quick and dirty Grafana dashboard. Minimum lovable product is don't call it a POC, don't call it anything like that. It's the product that you want your users to use, listen to their feedback, and build it out based on what they want, not you want. So going low code is fast, getting buy-in, building some quick dashboards. Everyone loves dashboards, everyone loves data. Utilizing cloud metric filters to have custom filters for data that you care about. Very underrated and very easy to do. Understand your batch and real-time needs. you could see having real-time actually adds a bit of complexity. So you only need that for the things that you really need real-time for. Most of the time, batch is enough. Don't overbuild for real-time when it's not needed. There are other ways to do that, but this is the way I've chosen to do it. Keep it simple and only build complexity in when you need to. Visualizing the events, super important. And enriching your event payloads. So make sure that wherever your event goes in your system, you enrich it with a date and time and what added to that event, because one day you'll wonder how this event got somewhere and you'll need to see the trace. And very useful for debugging later. So a saying I like, an MVP proves it works, an MLP makes it indispensable, or at least that's what I hope. So I also have a podcast, and I also have a co-founder who couldn't be here today. So this is her part of the presentation. So come and listen. We talk about cloud and AI topics. Without Georgia helping me, this product would not exist. So thank you very much for listening. I hope you could take something away from this. And if you've got any questions, I don't have time to take them here, but come and see me afterwards. Appreciate your time. Thank you very much.